I'm going to start a new project, and this project will allow me to etch my circuit boards a little better. Previously I was using a method called laser printer toner transfer, and the way that works, you print the design of your circuit onto some glossy photo paper, and then you iron that photo paper onto the copper board that you want to etch. Now, the problem that I had was that the plastic from the photo paper sometimes melted in between the tracks that I wanted to etch, and it was very difficult to remove. So I wanted to find a method that was more reliable. I did some research, and there's a way you can use ultraviolet light, and there are special resistant films that you can use that are sensitive to UV light, and you basically put the film on top of the copper board, put a transparency with the design of your circuit on top of the film, and then expose the whole thing to ultraviolet light, and that creates a better mask for you. There's no plastics that get melted. There's a chemical that will remove all the film that you don't need. So in order to be able to do that, you need some method of exposing to ultraviolet. There's a big source of ultraviolet outside right now called the sun. Unfortunately, that's a little unreliable as to when it's going to appear, and then all the accompanying rain that we've been having recently. I don't want to stand outside and expose my boards in the rain. I'd like to do this all inside. So what we have here is a UV nail gel dryer, and inside there are 4 tubes. I'm going to end up using 2 tubes. There are ways that you can do double-sided circuit boards. I'm not going to get into that right now. I'm just going to build one for single-sided boards, so I'm going to end up using just 2 and then have 2 spare. And this unit is actually quite compact. It has a single circuit board, which is the ballast board for the tubes, and then some timing circuitry. This particular unit will time up to about 120 seconds. So there's some connections in here that are related to how that timer works, and also there's a mode that you can put it into that means that the tubes are always on, and that's the mode that we're actually going to use. So really, I'm only interested in 2 wires out of this. I'm going to cut back the wire for the timer mode, and then the 2 wires that enable the timer to actually start it. And then I'll keep this board and use the whole of it and just ignore the timer part of it. Now, in order to be able to control these on and off, I don't want to sit there and turn a switch off. I'd like to do some kind of timing. I'd like to have some kind of display that tells me how much time I have left, and also have maybe some different modes that I can put this into. And in order to be able to do that, I want to be able to use an Arduino. Now, for an Arduino, we need to be able to switch some AC power on and off. That gets very dangerous. You can't just do it directly from the board. You have to use a relay. So I've got a quick demonstration as to how the relay works. So the circuit that I have is power, and then a switch going to an LED with a current limiting resistor. With the normal switch, you can see that I'm turning this off and on. Obviously, I don't want to be around all day turning this thing off and on for the unit, so I want to be able to control it using the relay. Now, the relay has 2 sides to it. First of all, we have the high power side, or the switch side, where there is a circuit that needs to be completed. There are 3 pins. One is a common power pin, and then there is one that is a pin for when the relay is normally open, and then one for when the relay is normally closed. Now, in this particular circuit, I want to be able to connect it to the normally closed pin, so that when the relay is activated, the circuit is completed. On the other side, we have 3 pins. 2 of them are to power the board itself. There's some LEDs and just some optocouplers and things like that that need to be powered. And then there's a signal pin to enable the relay. Now, the input side and the circuit side of this relay are isolated, which is a good way of being able to switch some high-powered circuits on and off. Now, what I'll do is I will connect up this circuit so that the relay will be responsible for turning the light on and off. So you can hear the click, and the click is when the relay is on, and you should be able to see that this LED is now lighting. So I know now that I can use this to turn the UV lamps on and off whenever I want to, and now I have to write a control interface to enable some modes, to start the timer, to set how long the timer is going to run for, things like that. But I know that I can switch something on and off using just the one signal pin.